Hello students, today we study about the tachymetric surveying examples. Examples related tachymetric surveying. Example number 1. The following readings were taken with the tachymeter onto a vertical staff. We have a horizontal distance is equal to 45 meter, and the stadia reading says 0.885, that is the lower hair reading, 1.110, that is the center hair reading, and 1.335, that is the upper hair reading. And again the horizontal distance 60 meter, lower hair reading is equal to 1.860, then central hair reading is equal to 2.160, and upper hair reading is equal to 2.460. Calculate the tachymetric constants. Okay, we have a formula. D is equal to F divided by I into S plus F plus D. F divided by I, that is multiplying constant, S is equal to staff intercept, and F plus D is equal to additive constant. F divided by I we denoted as A, and F plus D we denoted as B. For the first observation, the staff intercept S1 is equal to upper hair reading minus lower hair reading. Upper hair reading is equal to 1.335, lower hair reading is equal to 0.885. Therefore, S1 is equal to 0.45 meter. Then we have a formula. D1 is equal to F divided by I into S1 plus F plus D, and then F by I is denoted as A and F plus D is denoted as P, and put the value of D and S1 in the equation, and we get the equation number 1. 45 is equal to 0.45 A plus B. For the second observation, the value of S2 is equal to upper hair reading 2.46 and lower hair reading is equal to 1.86. Then the value of S2 is equal to 0.60. D2 is equal to, again we have a formula. D2 is equal to AS2 plus P. We have a value of D2 and S2. Put this these two values in this equation, and we get the equation number 2. By solving the equation number 1 and 2, we get the value of A is equal to 100 meter. Put the value of A in equation number 1, we get the value of P is equal to 0. Example number 2. The stadia readings with the horizontal sight at a vertical staff held 50 meter away from the tachymeter were 1.385, 2.380. The focal length of the object glass was 25 centimeter. That means small f is equal to 25 centimeter. The distance between the object glass and the true axis of the tachymeter was 15 centimeter. That is the value of small d. Calculate the stadia interval, and capital D is equal to 50 meter, and the upper hair reading and lower hair reading is given 2.380, that is upper hair reading, and 1.385, that is lower hair reading. Then here the data given: D is equal to this, S is equal to this, upper hair reading minus lower hair reading. The value of we get the value of S 0.995, value of F is equal to this, value of D is equal to this, 15 centimeter. We have a formula. D is equal to F divided by I into S plus F plus D. The value of D is given, value of S is given, value of F is given. Put all these values in this equation, and we get the value of I is equal to 0.005 meter, and therefore I is equal to 5 mm. Then example number 3. Staff held vertically at a distance of 50 meter and 100 meter from the center of a theodolite fitted with a stadia has staff intercept with the telescope horizontal were 0.500 and 1.000 respectively. The instrument was then set up over a station. Here we set the instrument at station P. The instrument was then set up over a station P, and RL of P is equal to 1850.95. The height of the instrument axis is 1.475, that is small h, and the hair readings on a staff held vertically at a station Q is equal to 1.05, 1.900, 2.750 with the line of sight is horizontal. Calculate the horizontal distance PQ and the reduced level of Q. First of all, we have to find out the value of A and B, that is the multiplying constant and additive constant. we have a two observation 50 मीटर एंड 100 मीटर 50 मीटर डिस्टेंस के लिए हमको दिया है स्टाफ इंटरसेप्ट 0.5 एंड 100 मीटर के लिए दिया है हमें स्टाफ इंटरसेप्ट 1, that is S1 and S2 and D1 and D2. Put we have equation D is equal to A into S plus B. Put the value of D and S1, D and D2, D1 and S1, D2 and S2, and we get the two equations. Solving these two equations, we get the value of A is equal to 100 and put the value of A is equal to 100 in equation number 1. We get the value of B is equal to 0. The calculation of the horizontal distance PQ. So then in second case we set the instrument at P. We have a RL of P is equal to 1850.950. RL of HI, that means central hair reading. RL of HI, that means height of instrument is 1.475 meter. Okay, and 3 hair readings is equal to upper hair reading is equal to 2.750, central hair reading is equal to 1.900, and lower hair reading is equal to 1.050. Then we find out the value of S1. S1 is equal S value of staff intercept. Staff intercept is equal to difference between this deduction of the upper hair reading minus lower hair reading, or difference the readings between the upper hair reading minus lower hair reading. That is S is equal to 2.75 minus 1.05. That is the value of S is 1.7. Then we have a formula D is equal to AS plus P. Value of E is find out already find out. The value of E is 100. The value of S is equal to 1.7. The value of P is equal to 0. The distance PQD is equal to 170 meter. Calculation of RL of Q. The RL of Q is find out by the RL of P plus RL of HI plus RL of HI minus the central hair reading 1.9. That is the RL of Q is equal to 1850.525 meter. Example number 4. A tachymeter was set up at a station A and the following readings were obtained on a staff vertically held. The staff station is at benchmark and B, instrument station at B. At benchmark we take the angle of depression and at B we take the angle of elevation. 3 hair readings are given. RL of benchmark is equal to 850.50 meter. Calculate the horizontal distance AB and the RL of B when the constant of the instrument were A is equal to 100 and B is equal to 0.15. For the first observation, first of all we draw the figure from the given data. Okay, and the distance between the RL of benchmark and E is equal to D1, and the distance between A and B, that is D2. For the first observation, first of all we find out the S1. S1 is equal to upper hair reading minus lower hair reading. Upper hair reading is equal to, for the first observation, upper hair reading is equal to 2.600 and lower hair reading is equal to 1.200. From that we get the value of S1 1.400. We have then value of theta 1 is equal to 6 degree 40 minute, and put value of theta 1 and S1 in the equation D1. A into S1 cos square theta 1 plus B cos theta 1. Put all these values in the equation number D and B. We get the value of D and B. Value of D1 is equal to 138.26 and value of V1 is equal to 16.160 meter. For the second case, we find out the value of S2. Value of S2 is the deduction between the upper hair reading minus lower hair reading. That is 2.400 minus 0.800. That we get the value of S2 is equal to 1.600 meter. We have a value of theta 2 is equal to 8 degree 20 minute. Put all these values in the equation D and V, and we get the D2 and V2. D2 is equal to 156.787 meter and V2 is equal to 22.965 meter. RL of the instrument axis is equal to RL of benchmark. First of all, to find out the RL of instrument axis, RL of benchmark plus central hair reading, that is central head reading, that is v h central head reading, that is h1 plus v1. Okay, then RL of B. To find out the RL of B, the RL of the instrument axis plus the value of V2 minus value of H2. That is it at 9.925 meter. Distance ABDT is equal to 156.787 meter, and RL of B is equal to 889.925 meter. The example number 5, the vertical angles two bands fixed at 1 meter and 3 meter above the foot of the staff held vertically at a station Q where plus 3 degree 20 minute and 6 degree 40 minute respectively from the theodolite station P. If the instrument station is at P, if the elevation of the instrument axis at P is 101.520 meter, that means the RL of HI is equal to 101.520 meter. Calculate the horizontal distance between P and Q and the elevation of the staff station Q. This one is this example is related to tangential method. We have at the target 1 meter, we fix two targets at 3 meter and 1 meter. At 1 meter target, we have a angle 3 degree 20 minute. At 3 meter target, we have a angle 6 degree 40 minute. Okay, then find out the value of S. S is find out by 3 minus 1, that means 2 meter, and we have a formula D is equal to S divided by tan theta 1 minus tan theta 2 is equal to 2 divided by tan theta 1. Value of theta 1, theta 2 S is given. Put all these values in this equation and we find out the value of D. Value of V is equal to D tan theta 2. We find out the value of D. We found out already the value of D. Put the value of D in the equation number V, or equation of V is equal to D tan theta 2. Then find out the value of V, 1.99 meter. Elevation of Q. To find out the elevation of Q, we have a RL of HI is 101.520 meter plus V1 minus 1 meter. That means plus V minus H, 101.520 plus 1.99 minus 1, that is 102.51 meter. To determine the gradients between the 2 points P and Q, and the tachymeter was set up at another station R, and the following observations were taken keeping the staff vertical. Here the staff is set up at station P and Q and the instrument station is at R, and the vertical angle is equal to plus 4 degree 40 minute. Then second one is minus 0 degree 40 minute, that is angle of depression, and plus, that means angle of elevation. And the stadia readings are given 1.210, 1.510, 1.810, and for the second observation, stadia reading is 1.000, 1.310, 1.620 if the horizontal angle PRQ is 36 degree 20 minute. Determine the average gradient P and Q and take A is equal to 100, B is equal to 0, and RL of HI is equal to 100 meter. First of all, from the given data, we draw the figure. Okay, for the first observation, we find out S1. Value of S1 is equal to upper head reading, difference between the deduction of upper head reading minus lower head reading. Upper head reading is equal to 1.810 minus lower head reading is equal to 1.210, and we get the value of S1. Theta 1 is equal to 4 degree 40 minute. Put all these values in this equation. D1 is equal to AS1 cos square theta 1 plus B cos theta 1. The value of A is equal to 100. Value of S1 is equal to 0.60. Cos square theta 1 is equal to 4 degree 40 minute. Value of B is equal to 0. Then we get the value of D1, 59.60 meter. Value of V1 is equal to A into S1 sin 2 theta 1 by 2 plus B sin theta 1. The value of A is equal to 100. S1 is equal to 0.6 sin 2 theta 1 by 2 plus 0. We get the value of V1 is equal to 4.865 meter. In the second observation, by using the second observation, we find out the value of S2. Value of S2 is find out by the deduction or by the difference between the upper hair reading minus lower hair reading. The upper hair reading is equal to 1.60, 620 minus 1, that is 0.620 meter, and theta 2 is given 0 degree 40 minute. Okay, put all these values in the equation of d2 and v2. We get the value of d2 is equal to 61.990 and v2 is equal to 0.720 meter. Here the average gradient between these two staff stations, instrument is set up at R and staff is set at P and Q, and the angle between angle QRP is equal to less than is equal to 36 degree 20 minute, which is less than 90 degree, and we find out RP value, that is D1 is equal to distance between the P and R is equal to D1 is equal to 59.60 by using the formulas. And again we find out the value of RQ, that is D2 61.99 meter by using the formulas. Okay, and angle is angle RPQ or QRP is less than 90 degree. We have a formula to find out the value of QP or PQ. Okay, we get PQ square is equal to RP square plus RQ square minus 2 into RP into RQ cos PRQ. Substituting the value of in the equation 1, we get PQ is equal to, put all these values in this equation and we get the value of PQ is equal to 37.978 meter. RL of P, to find out the RL of P, we have a RL of HI is given 100 meter. RL of HI plus V1 minus H1, that is the RL of P. And to find out the RL of Q, the RL of Q is equal to RL of HI, that means this levels minus V2 minus H2, that is the RL of Q. Then the difference of RL of P and Q, the difference between the RLP and Q is equal to 103.355 minus 97.969 meter is equal to 5.386 meter P, where the RL of P is equal to 103 and 103.355 meter, and RL of Q is equal to 97.969 meter. That means the instrument staff station P is higher than staff station Q. Average gradient between P and Q is equal to difference in elevation between P and Q and distance between P and Q. Elevation, we already find out the difference of RL between P and Q is 5.386 meter divided by the distance PQ is equal to 37.978 is equal to 1 divided by 7.051, that is 1 in 7.051 fall. This one is your falling gradient because P is higher and Q is lower than P. Example number 7. Determine the gradient from the point A to point B from the following observations made using the tachymeter fitted with the analytical lens at the instrument station P for staff held vertically. Staff station is equal to AB, bearing is 130 degree, 220 degree, vertical angle is equal to plus 10 degree 40 minute, then plus 5 degree 20 minutes. Staff reading is equal to 1.360, 1.915, 2.470, and second staff reading is equal to 1.065, 1.885, 2.705. TK is equal to 100 and B is equal to 0. First of all, we have a bearing of A and B from instrument station. The difference between this bearing is 90 degrees, so we use the formula to find out the distance AB. Okay. Then for the observation 1, angle of elevation is given and the stadia reading is given. By using these stadia readings, we find out the value of S1 and theta 1 is 10 degree 40 minute. S1 is equal to upper head reading minus lower head reading. Upper head reading is equal to 2.4070 and lower head reading is equal to 1.360. And we find out the value of S1 is equal to 1.11 meter, and we have a formula d1 is equal to as1 into cos square theta plus b cos theta. The value of b is 0, then we have only formula a into s1 cos theta 1. Put all these values and we get the value of d1 and the value of v1. Formula of v1 is equal to e into s1 sin 2 theta 2 theta 1 by 2 plus b sin theta. The value of b is 0, therefore this term is 0, and we have a formula v1 is equal to e into s1 into sin 2 theta 1 divided by 2, and we get the value of v1 is equal to 20.19. Difference in elevation between a and the instrument axis. Instrument axis, that means central hair reading, and a, that means the elevation of a is equal to 20.19 minus the instrument axis is equal to 1.915, that means 18.27 18.275, that is v1 minus h1. For the second observation, again to find out the value of s2, then put this value of s2 and theta 2 in the equation v2 and d2, and we get the value of d2 and v2. Value of d2 is equal to 162.58, value of v2 is equal to 15.18, and the difference in elevation between b and instrument axis is equal to v2 minus s2. Value of v2 is equal to 15.18, and value of s2 is equal to, that is central hair reading, 1.885, that is 13.295. The distance d1 p is equal to 107.197 meter, and value of d2 is equal to pb 162.58 meter, and angle p app is equal to 220. Bearing of a minus bearing of b is equal to this, then difference is 90 degree. Then we use the formula ab is equal to p square plus pb square is equal to this. Therefore the value of AB is equal to 194.74 meter. Difference in elevation between A and B, the difference in elevation between A and B, so V1 minus H1 minus V2 minus H2, that is 18.275 minus 13.295, that is 4.98 meter. Gradient from A to B, the difference in elevation between A and B divided by the distance AB. 4.98 divided by 194.74 is equal to 1 divided by 39.10. Here the RL of A is equal to higher than RL of B, therefore we get the following gradient. Errors and the precisions. First one is instrumental errors. Errors due to the imperfect adjustment of the tachymeter. This error is occurred due to the permanent this error is occur because the permanent adjustment of the tachymeter is disturbed, so the error in the readings are occur. The adjustment of the tachymeter may not be perfect. The errors will occur. The permanent adjustment of the tachymeter should be checked. Corrective action may be taken if the necessary. Errors due to the staff or the stadia rod. The graduation of the staff is not read properly, so the error in the readings are occur. For that, correction should be applied. The graduation of the staff of the stadia rod may not be uniform. The errors will occur. The stadia rod should be standardized. Either the imperfect staff or rod should be replaced, or necessary correction should be applied. Errors due to the instrument constant, the value of A and B, value of A is equal to multiplying constant and value of B is equal to additive constant. If the multiplying constant A and the additive constant B of the instrument may not be correct, the errors will occur, and the constant should be verified by the careful field measurements or observations before the commencement of the work. Then second one is personal error. Errors due to the inaccurate centering and leveling. If the centering and leveling procedure are not perfect, the errors in the readings are occur. To eliminate these errors, the observer should ensure perfect centering and leveling of the instrument. Errors due to the non-verticality of the staff. To determine this error, the verticality of the staff should be ensured by means of a plumb bob or a circular bob or attached to the staff. The target, if provided on the steady error, should be accurately bisected. Errors due to the incorrect estimation of the staff intercept. Imperfect focusing of the telescope causes the parallax and may lead to the incorrect staff readings. The staff intercept should be accurately determined. If the staff is not clearly visible, proper focusing should be done and the sight distance should be such that the graduation of the staff can be seen very distinctly. It is advisable to read all the three hairs and to check that the central hair reading is the mean of the two stadia readings. Errors due to the incorrect reading of the vertical angle. The vertical angle is not if the vertical angle is not correct, then the vertical distance is not accurately we don't get the vertical distance very accurately. So the vertical angle should be taken very carefully. The value of the vertical component depends mainly on the accuracy of the vertical angle. Errors due to the natural causes. This one is refraction. First one is refraction. The errors due to the refraction occur due to the varying density of the different air strata because of the temperature changes. To eliminate these errors, the surveying work should be carried out in the morning and evening hours during the low temperature to avoid the refraction. Due to the refraction, the errors occur in readings. Then second one is sun. On a very hot day, the different parts of the tachymeter may expand, affecting the staff readings. And to eliminate these errors, the instrument should be placed under the shade of a tree or protected by an umbrella. Also avoid working in the hot sun. When during the high winds, the accurate work is not possible because as the instrument does not remain stable. Moreover, it is difficult to hold the staff steady and vertical. Then second one is poor visibility. Poor visibility is caused by a glare of the strong light coming from the wrong direction or due to the insufficient light. To eliminate such sources of the error, the instrument should be so placed that the sun does not reflect from the object glass, and in case of the poor visibility, stop the survey work when the visibility is poor.